Velocity is a word that really just means speed, but velocity actually has direction also. So a cannon shoots a cannonball straight up with an initial velocity of 50 meters per second. Here's that cannon, and that cannonball is being shot straight up. And if we thought about what this would look like, like in space, or if there was no gravity, that means that after 0 seconds it would be at 0 meters, and after 1 second it would be at 50 meters, and 2 seconds 100, and then 150. In other words, it would be linear because the cannonball would just keep going up. It would never stop. But of course we have gravity that's pushing down at the same time. So this is the gravity pushing down, and this is the velocity pushing up. Now the velocity starts out, pretty big, 50 meters per second, but it doesn't increase. Gravity never stops pushing down with its acceleration. But if without gravity, let's see, the equation for this I believe would be h of t equals 50 times t. It's just a line with a slope of 50. But gravity's there also, and it's pushing down. And so what we do is we add that negative 5t squared that you saw in the last video. And eventually, because t is being squared, gravity is going to overcome this 50t. It's going to get bigger as t increases. Negative 5 times the square of a number is eventually going to get bigger than 50, and then it'll come down again. In fact, so that means that there's a curve to this because the cannonball will go up. It'll reach its maximum height, which is about right here, and then it'll fall down again as time goes on, and it'll land on the ground. And so what I want to do is figure out what does that graph look like. I can do like I did in the last video. I could make a table of values, and I could start plugging things in. Like after 0 seconds, it's 0 high because 0 plus 0 is 0. After 1 second, it would be, let's see, 50 times 1 is 50, and then negative 5 times 1 squared is negative 5. So it would be 45 meters high. So after 1 second, it would not be 50, it would be 45 meters high. And after 2 seconds, 100, and then minus 20, it would be 80 meters high. So we could do this, and it would take a while, but we could make a graph of it that way. I thought the other useful thing to look at would be, well, where is the vertex, and what does that mean? So in order to find the vertex, I'm going to complete the square on this function. I'll do my work here. All right, negative 5, but I'm gonna factor that negative 5 out of both of those terms, and then I'm going to leave a blank space because negative 5 times negative 10 is positive 50. And the reason I factored that negative 5 out was so I could, complete the square. So half of 10 is 5, and 5 times 5 is 25. But then I have to subtract 25 on the outside. And so now this factors down to t minus 5 squared. This is the perfect square of t minus 5 squared. But then I have to also, here's that negative 25. So then I have to distribute the negative 5 back in, and I get negative 5 times t minus 5 squared plus 125. So the vertex. The vertex is at 5, 125, which would be 5, 125. It's about right here. And so we're looking at the shape of our parabola. The cannonball stops moving here, and then it starts to go back down. In other words, that's the maximum height. At 5 seconds, it reached its maximum height of 125 meters. And then after that, it would fall down in a symmetrical way because all these things are symmetrical, which means that it would land on the ground after exactly 10 seconds of cruising up. So it doesn't go up and up forever because gravity bends that line into a curve, and then after it reaches its maximum point, the ball sails back down. All right, so, and if I wanted to know exactly when it was, say, 20 meters high, I could use my equation or my function to figure out when was it 20 meters high. I could just set this equal to 20 and then solve it. And I'm not going to do that in this video, but you could probably figure out that you subtract 125, divide by negative 5, take the square root, and so on. And there's 2 places that it equals 20 meters high. So use these 2 ideas to complete Monday's assignment.